What's up, guys? It's Professor J Shizzle here, and today I'm going to be teaching you how to use the CURA software and export your model to 3D print. Let's go! Step 1. We're going to set up your 3D printer by opening CURA, setting up the printer, and importing your first model. Okay, so you've just opened CURA. Now, first step, you shouldn't be seeing this base plate. I've already set up a printer. Let's set up our printer. Normally, it should prompt you to add a printer. Of course, you gotta have a printer to print. So, first, add a non-network printer. Click it. And so we have ANETs and Enders. So, the first printer you'll be on is the ANET. ANET 88 to be exact. So, go down until you see ANET. Open it up. And ANET 88. Now, you click Add. Now, this has already preset all the different presets for it. Do not touch anything. Now, once we click next, we'll have this nice big build plate to import our model on. Now, how do we import our model? You can either go to File, Open, or go to this giant file icon. Click it. You will see a bunch of different STLs. How do you get STLs? Well, on Autodesk, if you go to the File, Print, hover over Print, and overwrite Send to 3D Print Service. This will export your model as a 3D model, such as an STL, so you can slice it. Now be warned, certain aspects, more complex aspects, such as threading and other stuff, like material, you're printing from plastic, you can't make it out of aluminum. Those materials do not matter. So if you have some super specific, I suggest you CAD it for real using extrude or some sort of other additive or subtractive method to make an actual thing you can see in dimensions. Now, part 3, open. And so there it is. That is how you import your model into CURA. Step 2, getting ready to slice. Modifying your model, going over some important settings and applications of those settings. Let's go. Okay, so we have our model, but it is incredibly small. Autodesk normally imports things at 1/10 scale. Now, this scale is in millimeters. All of this software uses the metric system. Remember that. So if you take your mouse button, click your little guy, you can actually have settings and scale it. Now, how do you scale it? We'll get to that. Now, first off, how do you move around your model? How do you see stuff? Maybe you design something, but you can't really turn around the model. Okay, here's how. Right mouse button is your friend. Right mouse button will rotate around the model. Now, make sure to hold it. Rotate. Now, two-handed user, remember, the shift button will make you move side to side and pivot the rotational point. Now scroll wheel will zoom in at a certain point. Move it a bit around. Now that is very small. My printer is named Mater. This is a nameplate for my printer. I know, it's super cool. So, now, let's scale it. So, you have your move tool, which you can move it all around. And then you have your scale tool. Now, let's zoom out, because it'll get a bit bigger than 5 millimeters. Now, if you put a 0 in any of the columns and press enter, they will all change to 1000%. That's 10 times more. This will be the actual size. Now, why does that do it? Uniform scaling. Now, if I click off this, and then Y0, click, hit a 0. What the heck? It's so squished. Yeah, you want uniform scaling. Now, again, this does it in millimeters. This will be incredibly thin. So make sure you always check uniform scaling. Rotation. This will be good for our 3D model to see, hey, can I rotate it in a better way to negate certain aspects like supports? And I'll get to that. So blue, about clockwise, counterclockwise, green, forward, backwards, and red, about side to side, depending on what your model is. Now, two very big things about moving and rotating. You cannot extrude under the base plate. You cannot extrude in midair. Remember this, because you will need to make sure that none of your model is up in the air. You can't print on air. Come on. Your move tool will be able to move it below the surface. This will not work. It's at negatives. It shouldn't be at negatives. Drop it a little bit down, and there you go. There's a mirror tool, but I don't want to mirror text because you can click it anywhere you want, just mirrors it. There's two other ones. They don't matter. They're not. Okay, now the good stuff. let's get into the settings. Now, extra course, I don't really want extra course. Let's do course. So, you will not actually see some of these settings once you click this drop down arrow. You can get very basic settings, but you don't want these. You want the advanced settings. You want your print to be as good as it can be. Now, if you don't see any of these settings, let's say you don't see quality, but you should see a drop down menu that says quality, you can print the little slider icons. You can click it and look at this. There are like 20 other settings that I don't have checked in. Support interface line length. What is that? You get width of a single line of support roof or floor. That's cool, but why do I need it? Of course, the most important one is the layer height. Or in all these other ones, if you get super if you want, go ahead and learn all of these, sure, be my guest. But the really sole one that matters, layer height. Now, layer height I have at 0.4. Our printers vary from about 0.1 to 0.4. 0.4 being the chunkiest layers, and 0.1 being your should be like only used for extreme like minute prints. You should not be using 0.1. It'll take hours to print. Walls are going to be your walls. So walls to the left, right. The walls and top bottom are basically the same thing, except top bottom are top and bottom, and walls are side to side. So walls and top bottom should probably be the same. Now, there's certain factors or settings that override others. You see, I have 0.4 millimeters, and the wall thickness is 0.8. If I press 3, wait a minute, 0.4 walls will not be 0.8. Yeah, 0.8 gets faded out. That means it doesn't affect anything. So it basically means it's obsolete because I said I want 3 lines. This is not bad. This just means that it is not following 0.8 wall thickness. It is following 3 wall line counts. So 3 wall lines, no matter whatever the layer height quality is. So we have that. So I normally want about 2. For these, top are going to be completely flat. Now, you normally want about 2 there. And see, this 1.5 got X'd out because I said 2. So 2 at 0.4 is 0.8. You can also set, okay, bottom thickness, I want it 0.8. See, it automatically changes it to 2. That's so cool. And see, you can maybe reset it. Boom, it resets following top thickness. Okay, it'll need 4 lines of that. Now, I want 2, and so it does that. And see, you can actually, there are functions in this program that will reverse it. So I can keep doing 2, and you see, it kind of grays out 1.5. Now, infill. Infill is very important. Infill is the amount of material put inside of the project. So it varies from 100%, it's going to be solid plastic, to 0%, it's just going to be a giant balloon. So you only want to use infill about 10 to 30%. And so about 20% infill will be perfect. 10%, and you really want to think about what is your model's purpose? Is it just going to be sitting on a shelf, no one's really going to be interacting with it? Or is it going to be used in some sort of prototype where it'll be hit, slapped, kicked, whatever? So if I'm like, it needs to be a little bit more durable, it can't really crinkle, I'll set that up to 30. If I'm like, it's sitting on a shelf, I don't want to spend a bunch of filament on this, I'll set it to a 10. Now this infill pattern. These are all different infill patterns. I suggest cubic. It'll make tiny little cubes about like diamond shapes. It'll be really strong on the walls and it'll be great. You can learn all these and there's not really much difference to print times. Material. Material is very important. If you don't get the right temperature, you won't print it correctly. PLA is normally about 200 to 220. ABS is normally around 240. Now make sure your printer can handle these temperatures. If you're printing something really weird like nylon, you need like 280 degrees. Our printers can't go to 280 degrees. Now, I normally print at about 220 for most PLAs. And if it's a weak PLA or it suggests printing at 200, make sure to check the filament wheel to be like, oh, it actually suggests 210. Go into the middle. It normally gives you a range, 215, 230. Print around 220 to 225. You don't want to go minimum and you don't want to go maximum and completely burn the filament. Build plate temperature. This will help your model stick to the build plate. Now, PLA like 60 degrees. 60 degrees is perfect. Don't change it if you're printing in PLA. If you're printing in ABS, you want to change that to 80 degrees. This will help it stick, but rule of advice, do not use ABS. ABS has a bunch of different problems with it. You need a much higher bed temp than we have for ABS. I would suggest strictly sticking with PLA for your first prints. Print speed and travel speed. Now, print speed is how fast it actually goes up and prints the little plastic on your model. Now, you want to set that to 50 per second so it doesn't mess up, lines don't get everywhere, or you're more of like laying bricks. You want to more of like smush them together and make sure they're in contact. You don't want to be laying it down. Travel speed. So travel speed is when it's not printing and it's moving from thing to thing. Use that move tool to move them as close together but not touching. Make sure they're not touching. If you have two separate things in the CURA software, you can actually smush them together. They will generate smush together. Make sure they have that separation. So that is very, very important. Travel speed, you can set that pretty high to make it go faster between prints. Enable retraction? Yes, enable retraction. That helps it so there's not a lot of strings. Stringing is when there's excess plastic going from part to part and it just looks bad. It looks like a cobweb basically. Don't want a cobweb. Z-hop? Z-hop is when it goes up and then goes down again. Doesn't really matter. Cooling, 100%. Leave that on. Of course you want the cooling fan at 100%. There's no reason why you shouldn't. Now, if I use my right mouse button, I go down, uh-oh, there's all this red. What is this red? This red signifies that
the underside of the model is not touching the build plate.
Again, you can't print in midair. So what do? You generate support. There's two supports, touching build plate and touching everywhere. Now, these take different times and they have different applications. Touching build plate, if you scroll down, only print at any of the red it sees basically from the build plate. If I have touching build plate, it'll leave about this square without any support. That's fine. You can have about a couple millimeters between plastic. It won't bend that much. But if you have a bunch, it'll go, it'll sag down. Make sure, think to yourself, if I print a single thin line of plastic, will this go down or will this stay relatively the same? Supports are plastic pieces put in to help build up your model after they've been printed. Do I want to try to fish out supports? Let's zoom out. Do I want to try to pull out plastic that's been kind of stuck in between a little alcove there? That's going to be pretty hard. So for this one, touching build plate is completely fine. For overhang angle, you don't really need this. There's zigzag support pattern. These really don't matter. There's not a time difference. So that's support. Just extra plastic to help it not wilt down. Build plate adhesion. Wait a minute, we just did bed temp. There's another build plate adhesion? No! Build plate adhesion is actually a way to warm up the extruder. There's going to be leftover plastic or not extruded plastic in the extruder, and it just goes around the model. So there's 4 different types: skirt, brim, raft, and none. So skirt will make a tiny little outline. I highly suggest skirt. There's no reason you should be using brim or raft. Raft is basically printing a big square of plastic underneath it, and then prints a little bit on top and then starts building. I don't suggest it. It really doesn't work. Skirt, on the other hand, it just warms up the extruder, does a couple lines. You can see the skirt line count 1 and skirt minimum length. Minimum length, if you set that at 0, if I have 1 skirt line, that's not 250 millimeters. So if I set this to 0, the minimum length, and just hit 1, it'll actually do 1. If I have it at 250 minimum, it will go 1 or 2 times, even though I've set it to 0 even. Make sure you have a skirt. It's the best way to warm up when you're printing. You want to watch it. Make sure the skirt has a good amount of plastic extruding. There's still no plastic extruding when your skirt's done. Your model is going to start off without the extruder printing anything. That's bad. Print stuff when you're printing your model. Come on. Number 3, reviewing your slice. Making sure to review your slice through X-ray view. What does the slicing colors mean? Exporting your G-code. Let's go. You have all your print settings. How do I view how this will be printed? I generated supports, but doesn't that mean extra plastic? Why am I not seeing any extra plastic for the red? Well, this funky fresh button called the slice button, hence where the name, the software slicer, slices it to basically a bunch of pancakes. Now, wait a minute, this still doesn't look like pancakes. Go to the left, hit the preview button, and boom, it turns red. Uh-oh. Did I do something wrong? No, you did something completely right. Now, it'll tell you how long the print is, about 57 minutes. Tell you it takes about 13 grams. Wouldn't suggest the grams, the meters is where it's at because it knows what nozzle you have, and that's about how much length of filament. Now, you might be like, huh, that's a really long thing of filament. That filament is wrapped up so much, there's at least a kilometer in there. You're fine. So, okay, so 57 minutes, 13 grams. What do each of these colors mean? So I can actually take the slider. So you see the slider, it says 47. I can select it to a certain layer if I'd like, but these are all the layers. So it'll take 47 layers, 1, 2, 3, to get all the way up to the top, and then it's finished. So let's go down to a bottom layer. Now, if you can see, this is layer number 1. You can see the model, shadow of what will come, and so there's very important stuff. This grid is the support. Now, all this blue stuff, support. Now, what is this line outlining? Well, that's the skirt. And so we can actually see some of our settings in action. So, top, bottom, thickness. I said it's 2 lines. We go to 1, and then we go to 2. So I have 2 layers with the thickness. Now, if we go to 3, look at that. Here's our infill starting to happen. Now, I selected a very low infill, 10%. Now this means there will not be a lot of material in it. You can see it starts to build up, and it starts to, now you can't see the cube forming as you could see with a giant box, but you can actually see, okay, now look at this. 1 layer, 2 layer, 3 layer, 4 layer. Wait, that's 4 layers. Didn't I see the top is like 2 layers? No, that's the top and the bottom. So that's actually going to print the 2 bottom and the 2 top. Now, we will go up and you can actually see the infill. Now, I said how many walls? I said 2 wall line count. You can see the red outer wall and you can actually see the green. Basically, you can see exactly what the lines are going to look like. That's sick. You can see each individual line. So like I said, things to pay attention to is, what the heck is your model going to be used for? Is it going to be used for, oh, it's going to get ruffled and punched and kicked and whatnot? Yeah, I want to set that infill a bit higher. Now, what does that look like? Okay, I'm going to set it to 30%. Oh, where did my slice go? It won't generate it on the whim. It'll wait for you to customize, update all your settings, and hit slice again. Now, it'll still be in preview mode. And if you can see, that's a lot more orange support. And you can see the tiny little cubes start forming all the way down. That's a lot of support. And as you can see, the time and the meters of filament it used goes up because you're putting more stuff into the model. This is really cool. It will update the amount of stuff you need. Now, things to look for. You can see your supports. Make sure you have supports. And you can also see, okay, does the infill look like it would be sturdy? That infill looks incredibly sturdy. Do I need that sturdy of an infill? Maybe I do. Maybe I don't. Do all the layers look good? Do my top layers? I have 47. Okay, I have 1 top layer. 46, another top layer. 45, no top layer, because I have 2 top layers. Now, once I'm all done with this, you want to plug in a USB SD card. Now, you can find these by probably the CURA computer you're at, and it will be on a little rack. You can see the USB stick, and you can see the tiny SD card. These printers run on tiny SD cards. One of the printers has a SD card converter, basically a big line that goes, and you can plug the SD card in and run it from there. The other printer, you'll have to plug the SD card in manually. If you take the USB, plug in the SD card, and then plug it in your computer, CURA will actually recognize it, and instead of saved to disk, it will be saved to removable disk, meaning saved to USB. And once you save it, you can even eject it. Now, what are you saving it as? A model? No, you're saving it as a G-code. Printers will read this G-code